Okay, hello everyone. This is the second part of meeting 2. In case you did not watch the first part, make sure to watch the first part because I will be starting from this slide, which is what a Boolean type is and when do we use the Boolean and what are the Boolean operators. You see, a Boolean is either true or false. You see, this is a Boolean literal. This is true. So you can declare it such as boolean b1 equal to true, or you can have a boolean expression boolean b1 is equal 1 greater than 2. You see, 1 greater than 2 is false. So now you can use the Java operators for boolean. You see, less or equal, this is the equivalent mathematical symbol. Greater or equal. Double equal when you test for equality. Is the first value equal to the second? And not equal when you test if the first value is different than the second. Okay, there's a typo over here on the slides. It should be less or equal in mathematics. Less greater than after each other. Anyway, now you can read this example, but let me go to my flowchart, and then I will go to the flowchart of meeting 1, and then I will go to NetBeans. So I will do everything related to this part. Now let me start an algorithm. I have the following algorithm. This is my start. Alright, let me make a larger font. Okay, alright, this is the start. Now I will take an input from the user. Read number. I am reading a number from the user. Let me have a connector to the start and to this read number. Alright, so the user provided a value. Now I need to tell the user two things. The first is that the number is positive. So there is a possibility for the number to be positive. It's not necessarily a positive number. I need to do a test first. Or I can tell the user that the number is actually negative. So over here, the number is, let me say not negative, is not positive because we have 0. And let's not consider a lot of options. So the number is either positive or not positive. Only one of these two. It cannot be both positive and non-positive. So you put a decision over here. You see, this is the decision symbol. And you perform a test. Is number greater than 0? You see, if it is greater than 0, this means it should be positive. Now let's put the connectors. Let me put the connector. This is a straight line connector. I will go to this decision. Now this decision, I can have two connectors out of it because one of them is for a positive number. The second one is for a non-positive number. And I can indicate the path. Where would each one go? You see, I now have two outputs coming out of this thing. See the flowchart this way. You see it like the following over here. Let me modify the connector to the side. Here, let me remove okay, I think I can here it is. And let me put this over here, and let me modify the connector to be this end. You see, this is how you see it. It looks a little bit nicer. So either continue the normal path or take a deviation. You are free to use any design you want. And can you put more? Of course you can put more. Can you put more than one decision? You can put more than one decision. Anyway, this is not an issue. And let me put the terminal. You see, this is an algorithm, so it's you are free to do it any way you want, it doesn't matter, do not worry about it. All right, and this is my, of course, stop, this is my end. And now let me just continue. Like once I am at this output, I will go to my stop over here, and once I am at this output, I will go to my stop over here. It doesn't matter how you do it. You can even put your line coming to this one, so it's really the same. You can put them at the same location. It doesn't really matter. It doesn't really matter how you put it. You just indicate the flow where you have reached. Alright, now let me go to the meeting 1 slides. You see, this is the flowchart. Now, of course, this is a design, scratch, but the main idea is there. Start, input a number. If number greater than 0, you either go over here or you go over here. Notice that not always the result is the same or logical. Like number greater than 0, print positive, not print non-positive. You see, every path you might add a text to indicate why you are going to take this path. So when there is a decision, I will go to the general ones, I will get a plain text, I will put over here true. So if the value is true, then the number, okay, this true is over here, this is my path in my design. It might be different in the slides, it doesn't matter. And this is false if the number is not positive. So you are free to use any logical values, whether yes, no, true, false, positive, non-positive. So this is my design. Alright, this is it for meeting 1 for decision. You can continue all the slides about decision in meeting 1. There are several others, and repetition will be discussed in a later video. So that's it for meeting 1. I will come back to meeting 2. Now, how do we use decisions in Java? You see, in Java we have the if statement, and there is an optional else statement. So let me start by the if statement, and then I will go to the example of an if else. Everything is written over here. You can read them all together. I will explain everything in my program. So there's a one-way if or a multi-if. There are the curly braces. When do we use them? I will cover all of these slides, and then I will come back to the common errors. Let me start by a new project, and then I will take one of the exercises and I will do it using the if else. So this is just for explanation, and then I will solve one of the exercises of meeting 2. Alright, import java.util.scanner, scanner input is equal to new scanner of system.in. I need to take an integer from the user, int number. I need to give the user a prompt, system.out.print, enter a number, or let me make it clearer, enter an integer. So now the user is not allowed to give me any number. Number is equal to input. I use the scanner dot next int. Now I read it. Now I need to tell the user whether this number is positive or not. So I use an if statement. If I need a test. The test is very simple. Is number greater than 0? You see, this is the test you are doing. If number greater than 0 is true, what you are doing is checking the value of this Boolean expression, whether it is true or false. If it is true, you start a new block. Now, this is a block that can be either true or false. You might need two paths. Else, there's another block. Notice that in the else you do not perform any additional test. So now I have an if-else statement. Now if true, system.out.println, the number is positive, and in the else, which means the condition is false, number is not greater than 0, system.out.println, the number is not positive. Alright. Now let's test. Let me run. Enter an integer 9. The number is positive. Let me run it again. Negative 9. The number is not positive. Let me run it again. 0. Well, 0 is not positive. 0 is not positive. Now, in case you need to consider 0 as a positive number, here it is. If number greater or equal to 0. Now let's do a little bit of modification, but we do not usually consider 0 as positive. You know, it's positive, 0, and the negative. Now let's do some modification. I will remove the else altogether. You see, the else is optional. But in my program, this is logically incorrect. Like, I am only saying that the number is positive and nothing afterwards. Let me run this program. Enter an integer, 9. The number is positive. Excellent. Let me run it again. Negative 9. Nothing. Build successful. My output. This is the only line of output after the prompt. This is conditional. It's inside the if. And there's nothing afterwards. There's nothing afterwards. Now this problem is sometimes you need an if without an else. But in my case, it was logically incorrect. Let me go back over here, put the else. You see, here it is. Now it is logically correct. Alright, one more thing. The number, let me use a print over here. Let me add number, and let me write another system.out.println is positive. Alright, I did not modify a lot. Let me run this. Enter an integer. Here's my 9. The number 9 is positive. You see, I wrote it in 2 lines. Now, the if else, in case you have a single statement, no need for a block. Like, let me remove these. You see, I removed the block of the else. It still works. Enter an integer 9. 9 is positive. Enter an integer negative 9. the number is not positive. So everything is working properly, no errors. Notice when I will have an error now, what I will do. I will remove the block of the if statement. Now what happened is, if you do not put a block for the if, this means only one statement belongs to the if. This is not part of the if. Now this else does not belong to anything. You cannot have several statements without a block and then put an else. If you have several statements, now after the if directly comes an else. It doesn't matter if you add lines. This else is after this if directly, but do not write anything in between. Alright, another modification. Let me go back to the number is positive. Now I can remove the following block, because there is only one statement. Let me go to the slides. You see in the slides over here, where it is, oh, here it is. They tell you that you can use curly braces if you have single or multiple lines. If it's only a single line, there is no need for the curly braces. It is optional. Okay, let me take the common errors and then I will do an exercise. Common errors is when you put a semicolon after the if or the else. Be very careful. This is sometimes logical, sometimes syntax, because logical after the if means you are cancelling the else. In case there is no else, so it's logical. In case there is an else, it will give you a syntax error. But if you put a semicolon, means the condition finished between the curly brace and the semicolon. So the whole if finished. Never put a semicolon after the if. Take a look at my program. You see there is no semicolon. This line did not terminate. The else did not terminate. There is something still remaining afterwards. This is the conditional part. So do not put a semicolon after the else or after the if. Now this is a compilation. You see, this is logical, not compilation, because a semicolon without an else means that this line will be executed always. But if you have an else, now this else does not have an if. The if terminated. This is a statement between the if and the else, so this else does not have an if for it. So this is a compilation error. Alright, now before meeting 3, make sure to finish meeting 2 in full. And now I will be doing one of the exercises. You can do these exercises yourself. I will be doing exercise 3, number 2 and 3. You need to do all the exercises. You have the solution on Moodle. Now I will be doing exercise 2 and 3. I need to calculate the area of a triangle, and then I need to make sure whether the area is big or small, and I need to provide the result rounded to 3 decimal places. Notice that I might even write the solution different than what you have in the solutions on Moodle, because even if you wrote the solution yourself at a later time, like after 1 hour, you might write the solution differently. So let me go to NetBeans. Let me close everything and let me start a new project to do this calculation of area. And as usual, for simplicity, I will remove the comments and keep everything that is Java non-comment written. Alright, let me prepare this program to take input. So this is import java.util. Okay, I clicked something on my keyboard. Import java.util.scanner. Scanner input is equal to new scanner of system.in. Now I need to write my program. I can remove this space. My program will be here. Let me open it again. I need to read the base and the height as real numbers and then calculate the area. So let me first declare all my variable. I'm using real numbers, so double base, height, and declare the area as well right away. Double base, height, and area. Now I have my three variables. I need to read them from the user. Prompt system.out.print, enter the base. You can make it enter the base of the triangle, it's fine. So this is base is equal, use the scanner input dot next double, read another value system.out.print, enter the height, read the height using the scanner. So this is height is equal to input dot next double. You see, this part should be done very quickly. You need to become skilled. Keep on doing coding, keep on coding until you are able to write this part, which is the import statement, the declarations including the scanner, the prompts and the input all together. This should be very easy. This shouldn't take time thinking. Now you start thinking. I need to calculate the area. So area is equal. It is half base times height. There is a very common mistake over here. Let me go to the question. You see, it tells you use 1/2. Now unfortunately, if you put 1/2, the area will always become 0. This is a common problem. This will be explained in meeting 3. Do not put 1/2. The value of 1/2 is 0.5. So use 0.5 times height times the base and use a semicolon. So now the area is half the height times the base. 0.5 is the value of 1/2. Do not put 1/2, otherwise your area will be 0. Now let us provide the area and then do question 3. System.out.println, or let me use printf, I need rounded to 3 decimal places. Area is equal to %.3f \n area semicolon. You see, I used the formatted string. Area is equal 3 decimal places and the \n. Now let me run this. Enter the base. It's a real number, 2.73. Enter the height, 4.819. The area is 6.578, and of course it is half the product of base times height. You can try it on a calculator. Multiply this value by this value. You will get 12 point something divided by 2 or 13. It will be 6.57 something. So this is rounded to 3 decimal places. Alright, so this is the first program. This is the first exercise. Now let me go to the exercises. Modify the previous program so that after calculating the area, a message is displayed to indicate if the triangle is small or big. A triangle is considered big if the area is 100 or more, otherwise it is small. So let's do this update. Now you can keep this program as it is because you have already provided the area, and you can continue the code. You see, now I need an if else. I need to decide whether it is small or big based on a condition, based on a Boolean value. So I need to test if area is greater or equal to 100. Let me check. It is 100 or more. Yes. If area greater or equal to 100. Now I know it will be a single line of output. No need for the curly braces. System dot out dot println the area is big. Else system dot out dot println the area is small. You see, this is the update. It's just an if statement. Now the common errors, of course, do not put a semicolon. This will give you the area is big if the condition is true, and directly the area is false because the else has no body. Do not put a semicolon over here. You see there's an error. The else does not have an if. And in case you do not want to use the simple way, you can definitely always use the curly braces. They do not harm. So this is the whole program using the curly braces. Alright, now let me run it. This is the calculation and everything. So enter the base. This is here. Let me use different values. 6.29, and let me use a small value, 3.2. Area is 10. The area is a small. Let's run it again and have a big area. So this is like 25.34, and let me have 5.7 for the height. Okay, still I'm using half, sorry. Let me run it again. So this is 25.67, and let's have example 10. Now I will have more than 250, so it's 125, half of it. So yes, this is more than 100, so the area is big. I have used values to show that my area is big. Alright, this is it for this meeting. This was a continuation of meeting 2. So now you should have finished all of meeting 2. Make sure to work on all the exercises. Solution is available on Moodle. Thank you for watching this video.